Hello, welcome to tutorial number 10, where we're using Peter Amland's Ursina engine to make pandas, amongst other things, a Minecraft clone simulation. So, last video was dedicated to getting this little guy, what's his name? Greninja 28, named by Guy, um, moving around and following us. As you noticed, I've now spent 10 minutes to give him a much nicer texture. So it looks like a panda. I'm only generating 12 chunks of terrain at the start, I've just remembered. Anyway, let's generate a bit more and then turn that off. So we've got his animation working and things. In this video, I want to begin by just sorting out the rate of rotation. I ended the last video with a mistake. I was thinking that I could put in the second argument, so I passed in the second argument to the look at function, which is doing the work of turning our mob around like this. But you can see it's following me instantly. And you might want our panda friend to kind of look a little bit more slowly. So I found a way. I can't believe it worked, but there's just one line we need to code. So let's go and do that. So we can just use lerp, which we've used before. In fact, if I scroll down now, I'm in the main module. For where we move our player, our subject, down here, line 87 in the current version of the code, we are setting our subject's Y position, so up and down, using this lerp function, which is linear interpolation, which basically just means like moving something from A to B, like that. So we go from our current position, is the first argument, to the target position, Y, which will be, in this case, the height of the terrain block, and then finally, the speed of that interpolation. So what we're going to do in our mob system is, oh yes, by the way, I've got my 3 asterisks here, meaning, yeah, I've created a new texture. If you want that new panda texture, you don't want to make your own, I'd recommend make your own on Blockbench or whichever soft piece of software you want to. But if you want my one, it will be in the assets folder online. Link is in this description. So it's panda underscore texture, the new one. I think the old one was called panda tex. Maybe you like the old one, which makes the panda look like a cow. Anyway, so we've got, so our panda called grey, we've got turn speed, and at the moment I'm applying that here, as I said, line 15, yeah, our bug. This second parameter is not affecting our model at all. So in fact, we can take that out. So take that out there. What we want to do then is use linear interpolation. So what we're really doing is saying, well, our mob's rotation underscore y, so we're just using the yaw rotation, which is like that, equals, and so we want to use lerp and say, well, we want our current rotation, there we go, and now we need a target rotation. So what's our target rotation? So here we have a problem because our target rotation is a mystery. It's happening behind the scenes. We're using on line 15 the lookat function, which does all the work of finding the target heading and then rotating our model already. So we don't know what the target location is. So actually, what we want to do is say, oh really, our mob's rotation on the y-axis, oops, there we go, on the y-axis, is already the target. It's instantly moved there. So actually, that's going to be our second parameter, which is counterintuitive. So the first parameter wants to be what it was, the rotation, before we applied the lookat function. So in other words, we want to go and say, what's your original rotation? So maybe temp original rotation, temporary original rotation. So we'll just make that variable. This name, of course, doesn't exist as a keyword. I've just made that up. So temporary original rotation equals our mob's current rotation on the y-axis. So that. So now we can say we want you to move from this current rotation to whatever the look at moves you to point straight at the player, which is weird. So it does actually move it there. And then this line, line 18, is going to move it back, but then turn it a little bit towards that target. And then lastly, now we can, this is the crucial thing we're doing, or the reason why we're doing this is to be able to apply some timing to that. So then we can say, we can use our turn speed. So we can say gray dot, oh, so I'm in this function, aren't I, where whatever mob we pass into here will be referred to using the parameter mob. So mob dot turn speed, and again we want times time dot delta time to smooth that across different devices or running speeds on the same device. Okay, so that should work now. We'll just up the turn speed. So I derived that number from fiddling around with things and testing when it's not working. Turn speed not affected. Let's remove that. Right, let's run that. So mob system. Back in my, oh that's convenient, back in my main module, our main module, apologies, we are importing that mob system module, everything from there, via this line in the main module. Anyway, I'm back in the main module, and now I can run this to see if indeed our pandas, our mob's rotation is a bit slower. Oh, damn it, something's gone wrong. Frame animation 3D object has no attribute turn speed. That's just going to be a typo, isn't it? Because I've written turn speed with a capital S there, some camel humping. Down here, I wrote it all lowercase. There we go. And back to our main module and run. I've got a cup of tea brewing. I need to go and put some milk in that. So I'll have to pause this in a second. Oh, isn't that brilliant? Our mob, grey, has just disappeared randomly. I don't know if that's happened to you on your computer. Let me know in the comments. But sometimes, because of the loading, he falls down and disappears. That, we should write some code to address that issue. So we kind of need to check some, maybe in the mobs update, we need to say, hey, are you like -3000, i.e. have you fallen through the floor? Therefore we need to rescue. Okay, it's not there again. That suggests there's something wrong with my code actually. Okay, let's have a look at the code. What have I done wrong? Oh. No, I think we do need to keep this line 17 in there. Temp OR. Time dot delta time. Yeah, we've got delta time. Maybe decrease the turn speed, 0.1. This is what happens when you don't have a cup of tea. There he is, just walking away from me. Oh, is that what happened? Maybe he walked straight off the terrain. So I need to generate some more terrain. Oh, turning very slowly. No, it was faster before, so he would have, I don't know, looked at me immediately. Now he's walking. Got our animation running. Lovely. Now he's turning slowly towards me. Oh, going the other way now. Another thing, of course, that we'll look at is, glitching through the terrain here. Basically, we need to like kind of set a size for our mobs. I'll have a property of the size. So you might be standing on 4 terrain blocks. So in other words, we have to look at those 4 terrain blocks and move to the height of the highest one out of those four. I think that would be something like the proper result. Okay, so that's definitely moving at a different rate, so it's partially working. What I'm going to do in main is generate maybe 32 chunks, maybe 64. Mob system. So we want him, moving at maybe 10 times as fast. What have I done in my prepared code? Mob system. Speed 1. Interesting. Let's have a turn speed of 1. And then run that. Oh, let me pause it. Go and get my tea, and then I'll run it together. Pause. And we're recording again. Right. Press play. I'm in the main module. So it might take a little longer to load this time. I set it to, what was it, 64 chunks. That's not too bad. And so it means our panda friend, Grey, won't fall off immediately. So he's looking at me. You know what we'll do? At the moment, sorry to restart again, but he's part of his instincts are saying, how close can they approach? So if he's 10 meters or 10 units away, then he's not going to get any closer. Let's say you can get 3 meters. Get within 3 meters of me, Grey. So I want to just see a bit more interaction, a bit more intimacy. But I was happy with how long that took to load. That was okay. Oh, can you believe it? He's glitched again. I really want to know what's happening there. So in the mob system, in terrain walk, let's just put something here. Might be a bad place to put it, but check mob hasn't fallen off the planet. No, I think that needs a winky face. So what we need to say is if mob, as we pass in the mob's what's it called, frame animation 3D objecty thing, if mob.y is less than, I don't know, minus 100, then mob.y equals 32. Hopefully that's something like being in the air. We'll put 100 in the air. Oh, okay. And then we'll say mob dot. Oh, it'd be nice to put them in front of the subject. Anyway, let's just try that. Let's see if it. Oh, and what we should do is, sorry, print something out, a little debug log. Print to the console. I've fallen off. Oh, and I'll do double quotes there so that we can use apostrophes without a problem. There we go. Inside the string. Right. Okay. My goodness, it's almost 15 minutes in, and all we've done is kicked a panda off the planet a few times. He's off again. So, anyway, kind of like, oh, he did appear in the air. And is he falling now? Yep, there he comes. There he is. And he's kind of doing a strange wiggle. And now he's turning to face me. And he's getting more intimate. There we go. So that's 3 meters away. If I go this way, yeah, he turns like more slowly. So this is, so we've done the thing that we want to do is use some linear interpolation to slow down or speed up the rotation of our models. I'm reminded kind of Minecraft when an animal comes up to you this close. Often they look at you. So you can think for yourself, I'll develop this later on, but you can think for yourself and use what we've put in place already to accomplish this for yourself now. If you're anxious to do it, you could have a system whereby the head is animated kind of independently and follows the player almost instantly. and that's which gives a lot more kind of like liveliness to the mob. But anyway, I like that. So there is a bug at the moment in if we go like behind them, he does a weird wiggle dance. I'm very proud, by the way, of the texture of the tail. I think that's really good. Oh, there he goes, a wiggle dance. So it looks like we've given the panda some clever and interesting AI behaviors. It's just all bugs. It's all bugs. And it's probably a combination of look at not being used quite correctly and this rotation hack. So at the moment, our model is reversed on the z-axis, so its forward orientation is inverted. So we've used this little hack. So I don't know now if we take that out. Presumably that would make the animal flee from us, i.e. they would point away. I think what's happening perhaps sometimes, depending on the loading speed, there he is parachuting in. I think the mob must load more quickly, than the terrain, and therefore is underneath the terrain. So you kind of overtake him. Yeah, he's running away from us. Oh, and we're not taking out the we're not taking out the unwanted rotations now. Which kind of looks good when he's running away from me up an incline. It looks like he's tipping upwards, which is nice. Yes, there we go. Have I got the cheat sheet up? I have. There might be a way. I did just read something. Was it just to do with entities about reversing it on the z-axis? Reparent to get position combined. Flip faces. Oh, look at 2D might be better for us. I think it is on here, isn't it? Set position. Oh, there's also smooth follow somewhere, which might be a better built-in way of getting our mob to follow the player. Combine flip faces, get position reality, reparent to generate cube map, set shader input, attributes bounds. While I'm just looking here, a few people have commented about using a shader, which I'd absolutely recommend, but I'm using a Mac, and so the shaders won't work yet, or I haven't found a way to get them to work with Ursina's inbuilt like shaders and things to work there. I did try it on a Windows machine, and there was also a problem. I got lighting working, the shaders working, but it didn't work with the texture atlas. Basically, it set the texture atlas to every single, like the whole texture atlas to every single block on the terrain, which is a big problem. So I kind of abandoned that. I was talking to someone on the issues page. Let's have a look. Sky and Moon, was that it? Just to jump to something else. It's loading really slowly. There we go. So it's DanCap07 had some nice ideas about using the moon and the sun and rotations. Oh, and I didn't go into detail here. No, it must have been on another comment. Anyway, basically, I was thinking the way Minecraft works is every like block area in the whole world has a value for how light that area should be. So like where I've applied different random tints or shades to each like grass block, you could have a look at how far down underground it is and get darker and darker and darker, or what time of day it is to get darker and darker and darker, and then apply that color to the entity, to the texture. Also, we can use fog density, and we could apply like a black color for nighttime, and then get the density could get thicker and thicker and thicker, and so creating like a nighttime effect. So we can do some things with lighting without using shaders. So we'll experiment with that. Anyway, I was looking for. I'm sure there was something about forward. Get the forward direction. Get the backward direction. It's like resetting the forward direction of an entity, and I'm sure it said it. In here somewhere. What I'll do, I'll pause it so I'm not just looking through a list on screen, and then if I find anything or not, I can unpause. Okay, so didn't find it. However, I did find smooth follow, this function here. So it looks like we can set a target, offset from that target, speed and rotation speed. So we might be able to use that one line. You can experiment with that yourself, and it might be able to achieve in one fell swoop what we've done in our mob movement with several lines. So yes, I'd recommend that, having a look. I might have a look at it later on. Anyway, the second thing we want to do in this, or the main thing we want to do in this 10th tutorial video, is sort out collisions for walls. So, I've got my prepared code here. So this is what we're going to do. So an overview, so you can get straight to the code if you want. We're going to write a new module called like bump or something like that. And we're going to pass into the bump the subject and the terrain object. And it looks like, oh look, I've put in these lines from the top of the main module. Sorry, the top of the terrain. The terrain collision walking around algorithm that we've written so far, so that the player is on top of the terrain. So we've taken that top bit off. So basically, we're writing a module where we can finally get our walk script stuff removed from the main module, which is good news. So we're also looking at walking into walls as well. So it's kind of like horizontal collisions and also vertical collisions as well. Right, so what we've got is now a function inside this function, which I haven't used often, and that's called check bump. So it returns true or false, so are we bumping into something? And then I've written a comment here, input F, what does that stand for? Is the location of the block ahead, behind, side, etc. So it's the location of a block, and we're going to check if we're bumping into it. And what have I written? A little for loop. I in range 1 step 1. So that it looks like it's checking from the player's kind of midriff height, or your knees upwards, and saying, is there any block there? Therefore, return true. And to see if there's a block there, we're checking the terrain dictionary. And if we see a T mark there standing for terrain, there must be a block there, so it returns true, else returns false. Now I've got some new settings. I'll go over this when we build this. How close can we get to that wall? So I'm saying 0.555. That's how far we're checking ahead of us. Then we're getting that position. Actually, the R position is the subject's position, rounded. not floored. And then the subject's forward is the subject's forward where we're facing, and the subject's forward dot y is 0. Oh, so we're kind of like zeroing off the y axis. In case we're like looking up or something like that, we just want forward straight ahead of you, not like looking up, because the steeper the angle, your forward might be hardly forward at all in terms of x and z. And of course, we want to check x and z in terms of vertical bumping. Now I'm saying b direction, that must be bump direction equals, so our position plus the subject's forward multiplied by, or how close are we going to check? And then we pass that b direction, that possible bump direction, into the check bump function. That's inside of our bump wall function. And so what that does is take hold of that direction, that location, and it just looks up and down on the terrain dictionary because they've got different y positions. So you might be able to bump into something there in your head or something a bit lower down. So it has to check up and down. Now I've written a function here because we also want to then check if that's happening behind us, left and right. So where I've written subject forward before, then we also want to look at minus subject forward, so that's behind us, or to the subject's left, to the subject's right, and so on. So all of those will have to do that check of looking up and down the dictionary on the y-axis. So that's why we've got a convenient function to do that for us. And you might notice, wait a minute, why have I got this check bump at that forward position, for example? Why am I also looking at that direction plus left and plus right? Well, I noticed when we're bumping into something and we come from a diagonal, we might go straight through the wall, and also we could walk at a diagonal at a wall and still pass through it. So we want to kind of look at the block or the space ahead of us, but also the space left and right. So like 3 blocks altogether close. And if we do bump into that, it means that we are going to like hit that object. So all those positions, according to x and z, need to be checked. And then this function checks all those positions up and down the y-axis. So this check bump thing will be referred to a lot because we're doing all 4 directions, and for all of those 4 directions we're checking 3 blocks. So there's a lot of checks going on. Okay, so I've written I've written that function for that reason. Right, and then yes, underneath that, so it's right, left, behind, and in front. And what we do, once we pass those areas to check, are we bumping into something? If we return true to that, i.e. we find some terrain in that position, so we're going to bump into it, or sidestep into it, or reverse into it. So we return true, and then if that's true, we say held keys W, so that's walking forward, equals 0. So even if the player's got their W held down, we're immediately switching that off. So you can't physically move anymore. That seems to be the best way of doing it. I experimented with physically moving or kinematically moving the player backwards, turning their speed off and on, and nothing worked quite as well as this. So that's the method I'm using. And so if you're going backwards, then S will be needed to be turned off, left A and D. So WSAD. Obviously change the keys. If you're using the arrow keys, use the corresponding arrow keys here, or whatever keys you're using. There we go. So underneath that is the, actually I should label this again. This is our walking script, walking on the terrain itself. There we go. So this is what I've yoinked out of the main module and brought here, which is lovely. And then we've got our original lerp. Okay. and our gravity at the bottom. So that's this code at the bottom is exactly the same. Now, what's slightly different is we haven't got the variables to do with step height and things here, because we use those actually in our calculations for vertical collisions. So we set those right at the top. The most important ones are the x, z, and y, the subject's present position, and we want to round those instead of flooring them. So we've got a step height, and we've got our player's height. Block found is set to false to begin with. Right. In fact, because I've explained all of that, and the code is available for you to kind of like copy and paste or have up on your screen to write yourself, I don't think I'll recreate it from scratch, since I think that's fairly simple to explain. But let's incorporate this in our code at least. So I need to save this as, or rather, let's go and create a new module. I also have to set my language here and set this to Python, and then we'll call this vertical collisions, i.e. not ghosting through walls, etc. Oh, you know what? No, it's like subject terrain collisions. There we go. Okay, and save that as in the, as always with a new module, you want to save that in your project folder, in the main part of your project folder, so not in an assets folder, and we want to call this bump system. .py. There we go. Okay, so now I'll go to my prepared code, copy everything, place that in our bump system. There we go. And now what we want to do in main, at the top there, is from bump system underscore system import everything, I'm presuming, and then so I'm in my main module obviously, so then in update, down here where it starts at block found, here we shouldn't need any of this, so hopefully I could just delete that. Yep. And then say what's it called, bump wall, and then I've got to pass in the subject and the terrain. And let's just write a little note to ourselves, which is check for really walk on solid terrain and check wall collisions, save. So that should be referring now to our, just bring the bump system over here, should refer to this. So everything in here should be incorporated. Okay, let's see if that runs. I think I've saved everything. Wonderful. We're at least walking on our. Oh, I'm going to sneeze. But pause it. I can't pause it because I have to come out of here. Oh, I'm okay now. Since I'm out of running this mob system, we need to stop our panda running away from us. So I have to reincorporate this, although it's got a wiggle bug. Oh, let's think. Rotation is that. Yeah, temporary rotation is that. Look at that. Yeah, we do want to incorporate that. What did I do in my prepared code? Mob system prepare code. Yeah, I did exactly the same thing, so it's fine. Right, and we'll replace this comment, turn speed not affected, because we sorted that out. We'll say bug wiggle walk when aligned with subject, something like that. So we get a wiggle walk. Okay. Yeah. Oh, yep. So that's fine. So we've taken out the X and Z rotation, and we're leaving in the yaw rotation. And it should now be our panda grey should be now facing us as we expect. And what we're doing is testing the terrain in the wall collisions, which, as I said in the previous video, as a preview to this new ability, here we go, transforms a kind of the sense of reality. So let's build a wall. So now it's 3 blocks high. So for my settings, the step height is 2. Lovely. And it stops us in our tracks, and we can't sidestep through. We can't reverse through. Lovely. So that works beautifully. And if we put a block on the floor, we can step up and step over. Lovely. But we can't. Oh, can we get it back down? Oh yeah, because they're only 2 high relatively. Oh, remember, a panda has got a higher step height, so it's straight over. Oh, also, we haven't actually turned on the collisions, have we, for our panda? So he can walk through things. So maybe as an exercise, you could continue your own development of the mob system by copying the code into his movement for these collisions. Yeah, so just to reiterate, all we're doing is, for the vertical collisions, we're just saying from 1 unit up to the step height of our player, is there a block in the immediate square in front of them, or that one, for the heights from about 3 up? If there is, then we turn off W. If there isn't, we can keep using W, and now I can't get through. Lovely. Okay, so I haven't really tested this in terms of mining, so because there's a lot of colliding to be experienced down there. So whoa, I forgot how fast the blister mining is. Whoa. Oh, is that the panda? So I'm inside the panda now, so I can't like move at all. Oh, I moved a little bit. If I make myself a little tunnel here, hopefully I'll be able to walk forward. Yep. And now I'm kind of like trapped underneath that bit. Yep, I can walk forward and stuff, but I'm not glitching through, which is really nice. Okay. Wonder how fast I can get to the surface. If I can't get to the surface very quickly with my panda, then I'll abandon. Not the panda. Never abandon the panda. So what do I need? Oh, what I need to do? Yeah, sorry, is just. Oh, what happens here when I? Oh, so I can build. Oh no, can't build there. I can kind of build through the terrain. That's bad. And get myself into an impossible position. What's going on? Oh god. So there's a little possibility that we have to sort out. Players can build themselves through walls by standing on something, or through ceilings. I can see in the console also our poor panda has fallen off the planet. But whoa! I almost fell off the planet then. But it's quite interesting getting into these problems. I love seeing underneath the terrain. So actually, it's working rather well, really. So I shouldn't be able to move much, and I'm not glitching through the walls and things. It's just that build bug. So yeah, so that's pretty cool. Okay, so I can't get myself back up to the surface, so I'll abandon it. Right, that's 40 minutes. That's quite nice. Next video, it'll be good to show you how to do saving and loading. Some people are asking about getting jumping working. So I might do that. Well, I'll aim to do that behind the scenes. Is there anything else? Trees, I guess. And then we're back into biomes. So within 10 videos, 10, 11 videos, let's be generous. Okay, 12 videos. By about 12 videos, we've caught up with the 22 in the previous series. Oh yeah, and adding an axe and some animation would be good. Yeah, and just having fun making more mobs appear. I can't wait to get loads of chickens running around, things like that. Making our own mobs. Oh, caves. Yeah, and actually developing the terrain. So getting like caves and different biomes. And again, engaging with our Perlin noise again would be a good idea. So next video, certainly we want to be able to save the terrain and load. So I've got that working. That's in actually my prepared code. I need to put it in its own module. But it's not much. That's how to load a world. That's the longest part. There, and then saving the world is there. A very small few lines, in case you wanted to preview that. Okay, or indeed copy that and use that. That will be in the GitHub repository. Right. Thank you very much for watching. See you next time. Goodbye.